So before we move on to some more problems, let's make sure that you've got it. So here are a couple of tries. See if you can identify which part of the function would be u, and then determine du, and see if you can find the integrals using substitution. What I'm looking to see on your paper when you do your math is x cubed plus 6x is going to be u, and then du is equal to 3x squared plus 6, and that's all times the differential dx. And by allowing x cubed plus 6x to be u, we're going to end up with u squared du. So here's the du in green. So then we rewrite this, the integral of u squared du. So this is really important to show your work here, so that you must show. You're going to get really good at this, in which you're going to want to skip steps, but make sure that you're writing this down on paper. And of course, u cubed over 3, you can go right to x cubed plus 6x cubed over 3 plus c. So if you want to skip that step, that's completely legitimate. Okay, the next one, again, check your work, make sure that you wrote down what u is equal to. So in this case, u is going to equal, I'm looking at the two expressions, or the two factors, parts of the factors, and I have that degree 2, when I find the derivative, is going to be a degree 1. So my guess is that I'm going to have x squared minus 2 as u, and then du is going to equal 2x dx. That's exactly what we have here. So we'll have the integral of the square root of u du, and then the integral of u to the 1/2 is u to the 3/2 multiplied by 2/3, and then we're going to substitute back in 2/3 times x squared minus 2 raised to the 3/2 power plus c. Now you might be thinking, what happens when it doesn't work out so nicely? I mean, it's great that it works out so nicely. You find u, du is exactly what's left over. What happens when you don't have that du that's exactly left over? For instance, in the second example, number 2, we can identify that u is going to equal 3 minus 4x squared. 3, u equals 3 minus 4x squared, and that du is equal to negative 8x dx. But wait a second, I only have x dx, and I'm missing that negative 8. So I need a negative 8 on the inside. So let me rewrite this so that you can see a little bit more clearly. So this right here needs a negative 8. So I have u squared, and then I need negative 8x dx. So if I put a negative 8 on the inside of the integral, I have to undo it. I can't just arbitrarily multiply by a number inside. So I have to undo it by writing a negative 1/8 on the outside, because negative 1/8 times negative 8 is positive 1. So we're going to undo whatever constant we multiply inside the integral, we're going to undo it by multiplying by its reciprocal on the outside. So now we have negative 1/8 times the integral u squared du, because now we have exactly what we need. Now you can't generate variables inside the integral, but you can multiply by constants because of that rule number 1 that we learned in a previous lesson. So this is going to equal negative 1/8 times u cubed over 3. And then we're going to substitute back in our expression for u. So I've got negative 1 over 24 because negative 1 over 8 times 3, negative 1 over 24, times u cubed, and u cubed is going to be 3 minus 4x squared cubed. And then don't forget plus c. Or you might have 3 minus 4x squared cubed. If you're going to put the negative 24, I'd put the negative in the numerator and the 24 in the denominator and then write it like that. So either one of those will work. Okay, you try the one on the right, see if you can work with that constant that you need on the inside, and then just make sure that you're multiplying by the reciprocal on the outside so that you undo it. So you multiply on the inside. If you add that multiplier on the inside, you can undo it by multiplying by the reciprocal on the outside. Okay, and I'm going to show my work in blue here. U equals 3x to the 4th plus 1, and du equals 12x cubed dx. So we have an x cubed dx, but we need a 12. So I'm going to multiply the outside by 1/12 and the inside by 12. So see this 12 and this 1/12, when you multiply those together, you get 1. But this allows us to say u squared du. And the integral 1/12 times the integral of u squared du is 1/12 times u cubed over 3. So substituting back in, we're going to have 1 over 36 times 3x to the 4th plus 1. We're going to substitute that value for u back in, raise it to the 3rd power, plus c. And there's our answer.